In this video, I'm going to show you how to calculate one way to calculate the standard error, the difference between two related means. And the other way to think about it is it's the standard error of difference scores, paired difference scores. And so I've mentioned here just to remind you that the key of possibly all, if not all, inferential statistics is standard error. And I cover standard error in a lot of detail in an earlier chapter in the textbook, and I encourage you to check that out if you want to learn more about it. This should be just review for you that that's the case. And the standard error, the difference between paired observations, can be formulated in a couple of ways. I mentioned in the textbook that my preferred way is a little bit more complicated, but it also is more interesting and insightful, I think. And I talk about that in the advanced portion of the textbook. Here I'm going to show you the most common way that people represent and estimate the standard error of the difference between paired observations. So this is for a paired sample t-test. And it's the standard deviation of the difference scores divided by the square root of n. That's really what it comes down to. You just have to calculate the difference scores and then calculate the standard deviation for those difference scores and divide that value by the square root of n. So to show you that in more concrete terms, I'm actually going to calculate the standard error of the difference between paired observations in Excel. So we have the GPA pre-score and the GPA post-score for the study where they examined the effect of goal setting on people's university level performance. So to calculate difference scores for each case, so this is case 1 here, this is case 2, this is case 3 for pre and post learning the goal setting strategies. I'm going to calculate a difference score here. So that's going to be A2 minus B2, and that's a difference score, 0.45. And I'm going to calculate it for everybody. So I just double click the corner, and everyone now has a difference score. Now I note here that one person has a negative GPA, which is impossible. That's just part of the simulation program that I used to represent closely the results reported by the study that was involved with this. It just produced a negative value, and I didn't resimulate to not get a negative value, but it doesn't have an impact on the results. So here are all the data, all the difference scores, and now I need to calculate a standard deviation for those difference scores. And if you don't remember standard deviation, I encourage you to check out the chapter on descriptive statistics, because I assume that you already know what a standard deviation is. So to calculate a standard deviation, you just have to use this function here, stdev, open parentheses, close parentheses, whoops, get rid of that, and then put the range of values you want to include in it. So it's column C2 to C46. And here's the standard deviation, 1.061. Let's go to 3 decimal places. 1.061 is the standard deviation of the difference scores from pre to post GPA. And that standard deviation now needs to be divided by the square root of n. And we have a sample size of 45. We've got 45 paired observations. So what's the square root of 45? So let's just go equal SQRT 45, and we get 6.708. And now we just have to divide the standard deviation of difference scores. I've got that portion, the standard deviation of difference scores, and divide it by the square root of n. And then I'll have the standard error of the difference between paired observations. So let's just do that here. Equals C47 divided by E46. And that gives me 0.15815. So that is the standard error of the difference associated with the difference scores. Another way to think about it is that it's the standard error of the difference between the related means. So this group here has a mean. I can't remember what it is. Let's just calculate it now. This group has a mean. Go up here and average. And the mean is 2.25. And this group here, I shouldn't say this group, but at this time, post learning how to set goals, the mean is 2.909. So that is another way to think about it. So you can think about standard error in paired observations as the standard error of difference scores, and you can also think of it as the standard error of the difference between two means. I'm not going to carry on with the full analysis. Mainly, I wanted to show you the standard error of the difference between paired observations. And it's literally just the standard deviation of the difference scores, and then divide that by square root of n.